eddy currents. When there is a change of magnetic fields in a piece of metal, by Faraday's law of induction, an induced EMF is produced in the metal. Also, induced currents will circulate in the metal, and these induced currents are called eddy currents. Examples of eddy currents. First, floating ring. As shown in the diagram, a DC supply is connected to a solenoid with a ring placed on top of a cardboard, and a retort stand is put inside the solenoid. When the switch is closed, it is observed that the aluminium ring will jump up and then falls down. The reason is that when the switch is closed, a current passes through the coil, and this current will produce an increased magnetic field in the ring. Hence, an induced current, which called eddy current, will be induced in the ring to oppose the change making it. This magnetic field produced by the eddy current will oppose the increasing magnetic field of the coil. That means the pole induced by the ring and the pole produced by the solenoid on the upper end are the same. Therefore, the ring is repelled upward. When the current remains steady, the magnetic field in the ring remains constant. Since there is no change of magnetic field in the ring, there will be no induced current again. Hence, the ring will fall down due to gravity. If the DC supply is replaced by an AC supply, when the switch is closed, there is changing magnetic field in the rings all the time, so there is eddy current produced all the time in the ring to oppose the change making it, so the ring will float in air. The application of the concept of floating rings is widely used in magnetic levitation, 磁浮. Example 1. The weight of heat produced by the ring is the power equal to mc delta T over time taken, which is equal to mc is equal to the heat capacity of the ring, which is 30, delta T, change in temperature, 20 minus 15 degrees Celsius. The time taken, T, is 1 minute, which is equal to 1 times 60 seconds. Therefore, the power or the weight of heat produced equal to 2.5 watts. Swinging aluminium plate. Consider an aluminium plate is swinging into and out of a region of uniform magnetic field B acts in a direction perpendicular into the plane of the paper. When the aluminium plate is entering into the magnetic field region, the upper side of the aluminium plate will be induced north pole with eddy currents flow in the direction shown. When the aluminium plate is at its lowest position, there will be no change of magnetic field in the plate at this moment. Hence, there will be low induced current on the plate. However, when the plate is moving away from the magnetic field region, the upper end of the plate will induce south pole, hence the electric current flow in the direction so. Throughout the motion, the mechanical energy of the aluminium plate will be converted to electrical energy and finally go to heat dissipated. Therefore, the swinging aluminium plate will finally stop at the lowest position. This way, to stop a moving object is widely used in electromagnetic damping. An eddy current brake can stop a speedy train or a roller coaster. The strong magnets are installed on the track, and the speedy train is similar to the swinging aluminium plate. If the aluminium plate has slit is used, the eddy currents will be split into many small paths. In this case, the eddy currents will be decreased. Hence, the braking force will be smaller. And the aluminium plate will swing for more cycles before coming to rest. Induction cooker 電磁爐. An induction cooker has a circular coil of many turns N, which is connected to the AC. When the AC is switched on, the alternating current passing through the coil will produce a changing magnetic field towards the metal pot pasted above. By Faraday's law of induction, there will be induced EMF in the metal pot, or we say there are eddy currents flows on the metal pot, and this eddy current will heat up the metal pot. If we put water and food inside the pot, the food and the water will be heated up to a high temperature. As a result, induction cooker helps to cook food by means of indirect heating. That is, no fire is lit.